Introduction to Geometry. Yay! Some of you kept asking me, when are we going to get to geometry? Soon, and here it is. You won't need your protractors today. You will need them, though, at some point, probably next week. So we'll do, actually, our book doesn't have us using them, but the Zebras book does, and they really enjoyed it, and I think you guys were interested in doing that too. So for one day, we'll do a Zebra page, just so that you guys have that opportunity to use those. And it's important, it's good. Next year, you'll do a lot more of it, so it's good that you learned some of it this year too. All right, this is just basic geometry that you probably have already learned before. Okay, geometry means the study of space, and not outer space, but the space right here or the space over there. Okay, so distance, area. Okay, it's a branch of mathematics which involves the measuring of shapes. The word geometry actually means to measure the earth. Geo means earth, metry means measuring. Okay, then it says a point is represented by a dot right here. So we've been talking about decimals all year. In math, that can be a decimal, or it can be a period, or excuse me, a point. Not a period, that's language. A point, okay? So this is a point. A line segment is connected by 2 points. Let's see what they say for the definition. A line segment is represented by a group of points having 2 endpoints. Line segments of the same length are congruent. Okay, so this has a beginning point, an ending point. And if I were to draw another one the exact same, I'm not very good at doing that without a ruler, but if I were to draw another one that looks exactly the same size, we would call that, it's a fancy word, congruent. Congruent just means they are the same size, same shape. Okay, and then a line says it's represented by a group of points having no endpoints. A line extends indefinitely to infinity and beyond, indefinitely in opposite directions. So that's why there are arrows here. Okay, so I always say that a line is a lot like God. It has no beginning, he has no beginning, he has no ending. He is eternal. So this line would continue going on all the way around the world and come back and go across here and go some more. They just keep going, and that one goes that way. So it goes in both directions endlessly. Doesn't have a starting point or an ending point. Okay, but the next one, a ray, does have a beginning point but no end point. So I say this is a lot like us in our lives. We have a birthday. We have a day that started our lives, and we are going to live eternally somewhere, either heaven or to hell, the place of punishment. Okay, so this is like us. Some people think that we're like this. We have a beginning point and an end point, and we do on the earth. Everyone was born on the earth. Everyone will die on the earth eventually, unless Jesus comes back and rescues us first before we have the death day. So everybody has a birth date and a death date. We just don't know when it is. Okay, so a lot of people think of us as this, but we're more like this. We have an eternal soul that will continue on forever. That's called a ray. Okay, then what we have here are 2 rays joined together by one common endpoint. That's called an angle. I'm sure you know what an angle is. It has this little thingy here that's kind of showing us, let's see, does it tell what the name of that is? I don't know what the name of that is. No, it doesn't tell that. But one thing that I do need to point out to you is my mouth's not working today. I just finished the Zebras video and I couldn't talk in it either. I don't know what the deal is. Okay, vertex. A vertex is another fancy word to mean corner. Okay, when these 2 line segments touch each other and they create a little corner, right? And it's called a vertex. If it's an angle, then it's the center point of the angle. It's called a vertex. Fancy words, but all of this is very simple. Okay, so if you take out your papers, we're just going to go through these, and you have to identify them, and it's not too hard to identify them because it's right up there at the top of the page. Shows you what each one is. This one is a point, right? You know what? I'm just going to go zip through these really fast and say them. And if you can't figure, I'm sure you can, you're probably right now writing down the answers and not even listening to me, aren't you? I know how you work. Go up to the top of the page and just write down what each one of these are. I'm just going to say them. If you want to write them as I say them, great, but I'm going to kind of go fast. So the beauty of the videos, you can pause me. You can go spend an hour outside playing, come back, unpause, and finish your math page. So that's the nice thing about this. Okay, so instead of me writing them all, I'm just going to say what they are. Okay, so up here, that was the point. Okay, look at the top of the page if you can't remember. This one has an endpoint, or excuse me, a beginning point but no endpoint. That's a ray. This one has a beginning and an endpoint. That's a line segment. This one has no beginning, no endpoint. That's a line. Okay. Then over here, these are exactly the same size and shape. So these are called congruent lines. You may have to write the word congruent here and write lines underneath it. Oh, somehow we skipped over this. Intersecting lines. Here's a line and here's a line, and they cross each other at one point. We call that intersecting lines. You've probably heard that word when we drive. When we're driving and we go across a street light, like here's Woodlawn and here's 37th Street and here's Dillon's and here's Sonic, okay? And when we cross, some people are driving this way, some people are driving this way, some people are driving this way and this way, and we all pass each other here in this, well, one way, not all at the same time, but you know what I mean. We call that an intersection because the roads intersect each other or cross each other. So that makes it easy to remember. Intersecting lines. Again, you may have to write intersecting in the lines, write small. And then this here, did we talk about this? Oh, I did skip over some stuff, didn't I? Okay, sorry. Here's the intersecting lines that we just talked about. And perpendicular. Oh, how could I forget this? This is one of my favorite words. Perpendicular. I'd like to hear somebody with a good British accent say that. Perpendicular. I like that word. Okay, it just is a fancy word to mean that they intersect and it makes exactly a straight, what we call this is a 90-degree angles. 90-degree angles makes a nice, neat square. So if you can put a piece of paper on the corner and have it exactly square, in fact, they even label them like that. That's called a 90-degree angle or a right angle. So if they pass each other just perfectly straight like that, we call that perpendicular. Up here, is that a nice and straight way to cross each other? No. Those are just intersecting lines. However, these are intersecting lines as well. It's just that they are perpendicular to each other. Then you have sometimes roads that go along together, like this would be like 37th Street over by Dillon's. And then we travel up to Sunrise, and there'd be another street called 45th Street, right? And they both run the same way. And so we call that parallel to each other. Woodlawn and 37th are perpendicular to each other. Do you see? Okay, so also train tracks is a good way to say it. Train tracks have to be the exact same distance apart forever. If one train track starts going like this and the other is this way, what's going to happen to the train? It's going to derail. It's not going to keep going. Okay? It has to have its wheels, the grooves, are on the track. So if the track doesn't stay the same width, very important, the width exactly all the way across, then the train may derail. Okay? So those are called parallel lines. Perpendicular lines and intersecting lines. So these two are intersecting. Are these intersecting? No. And they will never intersect. They go on forever in both directions, and they would come clear around the world and never touch each other because they're an exact distance apart all the way across. Okay, oh, and then a plane. The plane is the one it's hard for me to understand. It represents a smooth, flat surface that has no thickness and extends indefinitely in all directions. It makes me think of kind of a piece of paper, but technically a piece of paper even has thickness. But it just has a surface that extends indefinitely in all directions. Okay, so now that we've covered all that, let's go back down here. And I gave you those answers. So now this one they want parallel lines. This one they want intersecting lines. We talked about this. And this one, they cross each other exactly, and they make that square corner right over here on the intersecting lines. Does that one make a square corner? No, sorry, Bob. None of them are square, right? Nope. But this one, you could put the square. You could put your corner there. You can put your corner there. You can put your corner there, and you can put your corner there. Every single angle is exactly straight, like a corner. And we call that perpendicular lines. And then this one over here is a angle. Good. Not angel, by the way. Kids frequently misspell these. That's an angel. And that is not an angel. Angel is spelled with an E-L. Angle is spelled with L-E. Okay? Then we come down to this section right here. I will help you with this one because you might find it a little bit confusing. Not really, though. It's pretty easy. Okay, true or false? And yes, you can just write T or F. I know what you're thinking. Okay, this first one says these two lines are parallel lines. True or false? False. Parallel, that train would not go, the train could not travel on those tracks. Okay, these two line segments are congruent line segments. True or false? Congruent, they have to be the same size, same shape. Nope, they're different sizes, so this one is not congruent. Okay, true or false? Intersecting lines can cross at only one point. Yes, true, because this one can keep going forever and this one forever, but they're never going to intersect over each other again, not with a line. A line is straight. These are curves. Curves are something totally different. So a line is a nice straight line, and they would never cross more than one point. Okay, the vertex of angle ABC is C. Is this the vertex right here at this point? Ah, you can't see, sorry. Okay. And it's off the page just a little bit. Okay, the vertex of ABC is C. Is this the vertex, the corner? Vertex is the corner? No, the vertex is point B. So this is false. Railroad tracks are an example of parallel lines. And you know what? I learned one year, I thought about this. The word parallel has two parallel lines in it. Those L's stand exactly side by side and make parallel lines in the word parallel. Okay, so are those good examples of railroad tracks? Yep. Okay, and geometry means to measure the universe. Metry was measure, metrics measure, was geo the universe? No, geo meant earth. So this is false. We're not measuring the universe, just the earth. Okay. So there's that section. I told you this was an easy page. That's all we're learning for today for geometry. I'm just double checking. You've got two story problems, both very simple. Okay, and then the back is the same stuff we always do. So this is interesting too. Read this little part here about geometry helping to build the Egyptian pyramids. It's amazing when you think that they built it way back. Let's see. Way back before Christ's time even. And they didn't have the special equipment that we have now to be able to do it. Anyway, this is interesting. Go ahead and read it. And I'll see you tomorrow.